So this lesson is talking about reflections, and you have seen some reflection stuff before, but you did it just with mirrors. So you can really think about reflections as when you look at yourself in the mirror in the morning, you see your reflection. It's just a transformation of you over what we call a line of reflection. So using this picture, we see that someone has written the word Bob, and that it's been reflected over this line right here. See, it's been flipped. So from here to here, it's just a reverse image. Much like when you look in the mirror, it's the reverse image of you. So this is called a line of reflection. And that's what we're really going to be dealing with today. So some figures actually have a line of symmetry, which is sometimes called a line of reflection, actually within the figure. For example, this is a line of symmetry because you can take that figure and you can actually fold it in half along that line. And then this would be on top of this would be on top of this, and so on. So because you can fold it in half, basically what it's doing is it's reflecting over that line, but since it goes right up to the line, it just really looks like we're folding the figure in half. So this one has multiple. It has 1 here, 2, 3, and 4. So it has 4 lines of symmetry. This particular figure, though, can only be folded in half over this line. So it's got 1. Most of what we're going to be dealing with is when we're reflecting over on a coordinate grid, and they can be reflected over either the x or the y axis. Eventually, you will be doing other lines of reflection in other math courses, but for us, we're just doing x and y. So a reflection over the x-axis will change the sign of the y-coordinate. I know that seems a little bit backwards, but we'll show you why in a minute. The y-axis will change the sign of the x-coordinate. So with a reflection, it's important to remember that it's actually the opposite of what you think should happen. Just like when you look in the mirror, it's not exactly you, but that reflection, you've been flipped. So when we look at this, I'm going to come up with the vertices first, and it's kind of hard to see on my board, so let me grab my paper copy real quick so that I can fill these in. I know on your booklets it's a little bit easier for you to see. Translations. All right, so those vertices are 5, 2, and 1, 3, and negative 1, 1. Okay, so again, A, here's my x-axis, here's my y-axis. A is at 1, 2, 3, 4, 5, and again, I'm a little off because I can't see it, and then 1, 2. So remember, you always do the x before the y. So those are our points. This is our original figure. I can tell because it just says A. Over here, it says A prime. That's how we say that. And this prime is noted by this little tick mark up here. And what that's telling us is that it is the new figure. Okay? Sometimes that's also called the image or the post image. But again, all those words just mean it's the new figure. So to find the vertices of my new figure, remember what I said a minute ago, is that when you are flipping over the x-axis, you change your y-coordinate. So we're going to do that real quick. We are flipping over the x, we're reflecting over that, so my x-coordinates will all stay the same. I'm changing my y-coordinates. So let's look at our picture and verify that that was true. A should now still be at 1, 2, 3, 4, 5, but now it's at negative 2 because I've taken this point and flipped it over this axis right here. So 1, negative 3. Oh, look, that is where it is. Negative 1. I forgot to change one. Negative 1 and negative 1, and that's where my C is. So as you can see, this has actually been flipped over. Here's our line of reflection. See, it's exactly the same distance away on either side. So it has, in fact, been reflected over that line. Now, additionally, let's talk about If you think about it, if we're flipping over this x-axis right here, okay, notice that it's at that same x, these are all x values. So notice that this point is at the exact same point x-wise as it was before. What's really changed is that the c was above the line before, and now it's below the line. So these are y values. That's why when we flip over the x, we change the y. Let's work another example. On this example, it's 2, 3, because again, I can't see my coordinates very well. 5, 1, 4, negative 2, and 1, negative 1. So I'm flipping over the y this time. So here's my y-axis. Okay, so notice it's 1 away, 1 away. Now, this y value here did not change. It was the x that went from the negative side to the positive side. So when I flip over the y-axis, I change my x values. And that is why, is because of the way it affects that graph. So my y values are all going to stay the same. And I'm going to go and change the sign. If it's positive, make it negative. If it's negative, make it positive, of all of those x values. And let's just verify. We've got negative 2, positive 3, negative 5, positive 1, negative 4, negative 2, and so on. So yes, it did in fact reflect it over that axis for me. Okay. In this one, we're going to be looking at a line of symmetry. How many lines of symmetry do these figures have? Well, if I split this, I could fold this top half down onto the bottom, and it would be exactly the same. So that's 1. I could also do that vertically and fold this half over onto that, so that's 2. So I've got 2 lines of symmetry. There is no way that I can fold a G over onto itself and make it be the same. If I folded this one here, this half would be smaller than that half. I can't really see any other way to do it, so this one also has 0 lines of symmetry. All right, so I've given you a grid. I'm going to reflect RST over the x-axis. Again, you're going to have to come up with those points, and those points are 1, negative 1, 4, negative 4, and negative 1, negative 4. We're reflecting over the x, so that should change my y values. So x stays the same, y changes signs. So 1, 1, that is r prime. Don't forget that prime because that tells me it's the new figure. 4, 4 is s prime. Negative 1, oops, sorry. I think I've got a typo in here. That t should be at positive 1. Sorry, I wrote the coordinates down wrong, which means this should be positive 1. So that t is going to be positive 1, and positive 4 should be up here. So that's why it's always good to figure out your coordinates and then graph, because you can see that this is a reflection over the x. Okay? And some people have problems remembering this part, so you could always just graph it, saying, okay, I know this is 1 away, so this has to be 1 away. I know that this is 4 away, so this has to be 4 away. You can graph it that way and then transfer your points, whichever works for you. All right, so we have the same coordinates here. This is 1, negative 1, 4, negative 4, and then positive 1, negative 4. Now we're reflecting it over the y, which changes our x values. So that's going to be negative 1, negative 4, negative 1, and these will not change. I'm going to go and verify that it works. R should be at negative 1, negative 1, so R prime is right there. And look, it's 1 away here and 1 away there. So S is going to be at negative 4, 1, 2, 3, 4, negative 4. So S prime is here. And then negative 1, negative 4, t prime is right about there. So as you can see, this has been reflected over the y-axis. All right, so that's all we have for this lesson. Please complete the next few pages in your workbook.